Hi everyone, my name is Ryan Anderson. I'm a planetary scientist at the USGS Astrogeology Science Center, and unfortunately I can't be there in person with you today because we're playing it safe with COVID, and so government employees have to stay home and can't come to fun events like that. But I'm happy to be able to record this talk for you, and hopefully you all will find it interesting. So let me switch it over to my slides and we'll get started. We'll start off with this sponsor slide presented by the Flagstaff Star Party. I need to make clear, just to follow the rules, that this slide does not imply endorsement by NASA or USGS, but these are the sponsors that are helping the Flagstaff Star Party put on this great event. So with that, I'll get started on the talk. I'm going to be talking to you today about the current events on the Red Planet. And we'll start off, this is a background image taken by the Curiosity rover looking out over some really nice scenery. You'll see this at higher resolution and in color in a few minutes. So I'm going to focus on the two Mars rovers. There's satellites orbiting the planet taking beautiful pictures as well. But to keep things brief, we're going to talk about just the rovers for today. The first thing to note in terms of the current events on Mars is where Mars and Earth are in relation to each other right now. This is a screenshot from the program Celestia that I made, and I set it to the time at which this talk is going to be given. And so you can see that Earth and Mars are on opposite sides of the sun from each other. It's not quite lined up with the sun quite yet, but in a few days we will be. And during this period where Mars is behind the sun or almost behind the sun and the sun's corona interfere with our radio signals between Earth and Mars. And so we can't talk to our rovers or our satellites around Mars. So we're in sort of a couple week long stand down where we cannot communicate with the rovers, and so they are doing some just sort of basic weather monitoring, sort of observations where humans don't have to be involved. The rover can just automatically make measurements for a while. So that will conclude on October 17th, and then we will pick up where we left off and continue roving around and exploring. But for now, the rovers are both sitting in specifically chosen locations and making environmental measurements, basically. But we can talk about what the rovers had been doing up until conjunction, and we'll start off with Curiosity. Curiosity is now the older rover. It landed in 2012 and has been exploring an area called Gale Crater. And you can see here, we landed way up here at this place called Bradbury Landing. We drove over to Yellowknife Bay, and then since then, over the years, we've been driving mostly southwest to get around this large dark dune field, the Bagnall Dunes. We crossed off the crater floor onto this new type of terrain, and this was the beginnings of our traverse up the flanks of Mount Sharp, or Aeolus Mons, this huge tower of layered rocks that we believe captures transitions in the environment in Mars's ancient past. And so over the past few years, the rover has been exploring this area from Vera Rubin Ridge and then down into this trough, which we knew from orbit contained clay minerals. And that was really one of the main goals of the mission, is to investigate those clay minerals, because clays only form when there's lots of water. So the rover's been doing a lot of studies there. We've also been exploring up on this interesting feature called the green hue pediment here in the middle. And we actually managed to drive the rover up onto it briefly. And that is what our next picture shows. So this arrow shows where the next image was taken. So I'll turn the slide. And so here's what it looks like from the ground. This cap here, these layered rocks with these tilted layers, that is the cap that forms the top of the green hue pediment. And those tilted layers tell us that these are sand dunes. This is petrified sand dunes turned into a layer of sandstone that is protecting the rocks underneath it. And that's why this thing is a pediment, which is just a surface that is resisting erosion. Looking down from the pediment, we can see down into that trough that contains all the clay minerals, and then mesas and buttes off in the distance, and then finally in the far distance, the crater floor. Looking ahead from nearby where we drove up onto the pediment, we had to take another sort of detour. We didn't want to just drive up the pediment because we wanted to come back down and explore some of these other layers. And so this was the view a while back when we started making our circuit around the foot of the pediment and working our way toward a valley that would lead us up into the higher reaches of Mount Sharp. And this campaign from here onward has been really interesting because we're looking at the transition between rocks that have a lot of clays in them and rocks that, at least from orbit, look like they have more sulfates in them. And sulfates are a different type of mineral that form with water, but they tend to form in more acidic waters rather than clays, where the clays form in more neutral waters that are more friendly to life. So the hope is that this transition in the minerals is capturing some important transition in the climate of Mars. And so we're slowly working our way up around the green hue pediment and up into the foothills of Mount Sharp. And as we go, as we climb up the hills, we're drilling holes and taking measurements along the way, making lots of observations. So this is a picture that the rover took of itself. The rover can take selfies. It has a camera on the robotic arm that it can reach out the arm and take pictures pointing back at the rover. And this is from a location called Mont Marcu. And this is starting to get into the sulfate materials. So we actually drove up on top of this little butte here behind the rover and drilled a hole right in the top of it and took a sample there. And we have since continued onward up up towards some of these hills that you can see in the distance. You can also see the hole right here that the rover drilled in the rocks at the foot of this outcrop. So in total, we have 33 drill holes now on Mars, capturing that whole traverse along the crater floor, and then as we work our way up Mount Sharp. And so those give us a really great picture into what the subsurface underneath the outer layers of the rocks looks like. You can see there's some interesting color variations. These colors are a little bit exaggerated, but not too much. And so the grays and blues tend to be rocks that are less oxidized, less rusty, basically. The reds and oranges are rocks that have more oxidized iron in them. And this one over on the left that's very orange was a picture taken during a global dust storm where the skies themselves were a deep orange color. So everything looked orange when we took that picture. And then this is a panorama taken not too long ago, and this is stitched together by Damia Buick, an quote-unquote amateur, but she makes better panoramas than I could ever make. And this is a view from approximately where the rover is right now, with a little bit of artificial sky added in to give a better picture of what it feels like to be there. And the scenery that we're in right now as we work our way up these buttes and mesas is just spectacular. So there's a lot of exciting stuff yet to come for this mission, but this is sort of what the scenery looks like where we are right now. And there's just a couple final things. This is showing one of the last things we did before we went into conjunction was we were looking at the rocks in this area. And if you notice, there's all these little nodules sticking out. And we really wanted to get a better look at them, but we can't really drill into a nodule like that. So the team came up with this idea to run them over with the rover, crush them, and then analyze the crushed pieces. And so just before conjunction, we managed to do that. You can see the rover's tracks in the sand, and then where the rover drove over some of these nodules, they've been crushed. They look a little bit more red. And so we've been doing some studies of those. So we'll know more about those as we come back from conjunction and are able to take a closer look. And so that'll help us put together this picture of what was water doing, how was the water changing over time as we go up Mount Sharp. And so this is the final picture from Curiosity that I'll show. This is a picture taken just before conjunction. Again, beautiful scenery. This is looking out across Gale Crater at the rim in the distance with the buttes and mesas of Mount Sharp itself in the foreground. Some beautiful sand ripples. So that's where we leave Curiosity. We'll check back in with Curiosity in a few weeks. So now I'll switch over to Perseverance. And I'll start off. Perseverance, of course, is the newer rover, the star of the show this year. And I'll start off with this spectacular video from the landing day. The rover and the sky crane that helped the rover land were equipped with cameras that recorded the actual landing. And so this video has the narration from the engineers at JPL superimposed with the pictures that we received later that contain all of those beautiful, mind-blowingly cool pictures. So I'm just going to click this and I'll stop talking for a few minutes and let them talk you through this.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
TRN safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
All right, so that's the video of the actual landing with photos and videos taken by the actual lander. You know, when we first landed, we didn't have all those videos. That we just got those sort of trickling back over the next few days, and it was super exciting to see those start to appear. You know, the landing itself was exciting enough, but then seeing actual pictures of it from the ground and from the sky crane, really, really amazing for everyone. This is the first color mass cam panorama of the landing site. And you can see that sky crane, that sort of jetpack that lowers the rover down to the surface. It has these giant rockets, and they actually left marks in the soil on either side of the rover that were there right where we first started. And then in the distance, sort of where the sun is glowing in this picture, you can see very faintly a row of mesas, and that's actually the edge of a big delta. A delta is sort of a fan-shaped deposit that's formed when flowing water encounters standing water and deposits a bunch of sediment. That's why we went to this crater Jezero crater, and so that's our eventual goal. But for now, the rover is exploring in the area where it first landed. Here you can see a zoom in on those buttes and mesas of the delta, just to show you, these Mastcam cameras have a really beautiful high resolution. So we've got really great images on this mission, even better than the Mastcams on the previous mission. And so if we go to the next slide, this is looking again at those mesas, and we can zoom in even more with the zoom on the Mastcams and see this really interesting outcrop. We had seen this from orbit, and we thought it was probably part of the delta, but landing helped us really be sure. And I'm going to show another picture of this that was taken a little while later in the mission, but it shows it slightly better and with exaggerated color. So on the top is the picture from Mastcam. Obviously the rocks on Mars are not blue, it's a little bit exaggerated, but that stretching also brings out some of the detail in the flanks of this outcrop. You can see these tilted layers. And these are sort of the diagnostic feature of a delta. You can see these pictures on Earth on the bottom. Here's a person for scale. Deltas tend to form these sloping layers where they're transitioning from water flowing in sort of a stream to water flowing into the lake. The sediment sort of slides downhill and forms these tilted layers. So seeing those tells us that this little butte is part of the larger delta, and that indeed that larger thing is a delta. Not that we have much doubt, but it's nice to have that confirmed on the ground. Perseverance also carried a little stowaway, the Ingenuity helicopter. This was a sort of technology demonstration to show that yes, you can actually fly something on Mars. And so this is a selfie that Perseverance took just after dropping the helicopter off. Perseverance then drove off to a safe distance, just in case the helicopter crashes. We don't want to crash it into the rover. But thankfully the helicopter did not crash. And so this next video, I'm going to play it and then I'll skip to about halfway so we can get to the good stuff here. But this is a video of the helicopter itself flying on Mars. So this is taken by the Mastcams looking off into the distance toward the crater rim. And there comes the helicopter flying in from the right. And then it's going to stop and go up and then come right back down. And this helicopter worked so well now that it's demonstrated that it can fly so nicely. We are now using it to help the actual science mission, scouting ahead, flying over areas where the rover can't get, and helping us sort of plan our route and get better pictures of the path ahead, even better than we can get from the satellites in orbit. So the helicopter has been this really cool tech demonstration that is now helping the mission with its actual planning going forward. So here's a map of where the rover has been. We've already been driving quite a lot. You can see up near the top is Octavia E. Butler Landing. That's where we first touched down. We explored a little bit in that area, and then it quickly became clear that we wanted to go down and explore this whole area around this sort of rugged sand dune filled terrain called Seita. And so we took a path down to the south around this point called Rubion. And we finally stopped at Citadel on this area called Artuby Ridge. And this was the place where we did our first successful sampling. We tried a sampling earlier, and the first sample we tried to get, the rock was too crumbly, and it actually just got pulverized by the drill and didn't make it into the sample container. So lesson learned there, but Citadel has been very successful. So here's a picture from Mastcam as we were approaching the location that we drilled, and then here's the selfie that we took where we actually drilled. You can see we drilled 2 holes in this rock, we double sampled it, and it was very successful. A nice solid hard rock that held together nicely. So we got a beautiful sample, and we have a little camera. Oh, first here's another view of the rock. Looking a little bit surprised with the 2 drill holes and a spot where we ground into the rock. We weren't trying to make a face, but in the process of investigating this rock, we made a little cartoon character face on it. And then we have a little camera looking into the sample tube, and lo and behold, there is a piece of Mars in that tube. And one of these days, Perseverance will drop all of its sample tubes once it's filled up its whole cache of samples. We'll drop those on the surface of Mars, and a future mission will pick those up and return those to Earth. So this piece of Mars will someday be in a laboratory on Earth, teaching us about the ancient history of Mars. So I'll leave this here. This is a picture from orbit. You can see the yellow arrow is pointing at the location that the rover currently is sitting at, a little bit down off of that ridge where it did the sampling. That's the rover, and that's where it's going to be sitting during conjunction. It'll be measuring the atmosphere, watching for dust devils, that sort of thing, and we will check back in with it on the other side of the sun once it emerges and we can communicate again. So that is what is going on with the rovers on Mars right now. So I'll leave it there with the sponsors again. Unfortunately, I can't take any questions because I can't be there live with you all, but I hope you've enjoyed this talk, and I hope you have a great time at the rest of the Star Party.